Question 12, Part D. A kitchen bench is in the shape of a segment of a circle. The segment is bounded by an arc of length 200 centimeters and a chord of length 160 centimeters. The radius of the circle is r centimeters and the chord subtends an angle theta at the center O of the circle. Part 1. Show that 160 squared equals 2r squared times 1 minus cos theta in brackets. The question is asking us to prove an equation, that is, the equation 160 squared equals 2r squared times 1 minus cos theta. And it's the presence of the cos theta that gives us a strong clue that the cosine rule will need to be used. So using the cosine rule on the triangle shown, we have 160 squared is equal to r squared plus r squared minus 2 times r times cos theta. Now collecting the like terms here, we have r squared plus r squared is 2r squared. We can also simplify this expression here, 2 times r, which is also 2r squared. We get 160 squared equals 2r squared minus 2r squared times cos theta. Now we can factorize 2r squared from both of these terms on the right hand side. So we get 160 squared equals 2r squared times 1 minus cos theta in brackets, which is the equation that we're looking for. Therefore, 160 squared equals 2r squared times 1 minus cos theta in brackets as required. Part 2. Hence, or otherwise, show that 8 theta squared plus 25 cos theta minus 25 equals 0. Using the arc length formula, L equals theta r, where theta is an angle in radians and r is the radius of the circle, we have 200 is equal to theta r. Now recall 200 is the arc length that's given in the question. Now I'm going to rearrange this equation to make r the subject, and the reason for that is because later on I'm going to use the equation from part 1 and replace r with its equivalent in theta. So from the equation in part 1, we have 160 squared equals 2r squared times 1 minus cos theta in brackets. I'm going to substitute 200 over theta for r here. So we have 160 squared equals 2 times 200 over theta in brackets squared times 1 minus cos theta in brackets. Now 160 squared is 25,600 and 200 squared is 40,000. Now 2 times 40,000 is 80,000, so what I'm going to do is divide 25,600 by 80,000, and we get 8 over 25 is equal to 1 over theta squared times 1 minus cos theta in brackets. Now in the next step, in fact I'm going to do two things at once here. I'm going to move the theta squared here over to the other side by multiplication. So I'm going to get 8 theta squared, but at the same time, I'm going to move this division by 25 over to the other side, which becomes multiplication. We get 8 theta squared equals 25 times 1 minus cos theta in brackets. Expanding the brackets on the right-hand side, we get 8 theta squared equals 25 minus 25 cos theta. Then we can move everything over to one side. I'm going to move 25 minus 25 cos theta over to the left-hand side. We get 8 theta squared plus 25 cos theta minus 25 equals 0 as required. Part 3. Taking theta 1 equals pi as a first approximation to the value of theta, use one application of Newton's method to find a second approximation to the value of theta. Give your answer correct to 2 decimal places. Let f of theta equal 8 theta squared plus 25 cos theta minus 25. We find the gradient function f dash of theta by differentiating f of theta with respect to theta. So f dash of theta equals 16 theta minus 25 sine theta. Now at theta equals pi, which is our first approximation, f of pi is equal to 8 pi squared minus 50, and f dash of pi is equal to 16 pi. Now we get that by substituting pi for theta here and here, which gives us our f of pi. Now cos of pi is equal to negative 1. So we have 8 pi squared minus 25 minus 25, and that gives us our 8 pi squared minus 50 for f of pi. Now this represents the y coordinate of the point of contact of the tangent to the curve where theta is equal to pi. Now the gradient of the tangent to the curve where theta equals pi, we use the gradient function and we substitute pi for theta here and here. Now sine of pi is equal to 0. So we're just left with 16 theta where theta equals pi, and that's how we get f dash of pi equals 16 pi. Now we have a point and we have a gradient, and we want the equation of the line that represents the tangent to the curve where theta equals pi. So we use the point gradient formula to find the equation of the tangent. So we have y minus 8 pi squared minus 50 in brackets equals 16 pi times theta minus pi in brackets. So that's our y minus y1 equals m outside of x minus x1. But in this case, we're using theta, which represents our x coordinate, and y, which represents our f of theta, or just our vertical coordinate. Now, Newton's method is based on finding the x coordinate of the tangent, which hopefully should be a better approximation than theta equals pi. And we do that by letting y equal 0, since the y coordinate of an x-intercept, of course, is 0. And then we solve for theta here. So letting y equal 0, so the equation becomes negative 8 pi squared minus 50 in brackets equals 16 pi times theta minus pi in brackets. So what I'm going to do is divide negative 8 pi squared minus 50 by 16 pi. So that's going to move over to the other side, becomes division, and that's where I get the division here. And then I'm left with theta minus pi on the right hand side. So this minus pi can also move over, it becomes plus pi. And we end up with negative 8 pi squared minus 50 in brackets divided by 16 pi plus pi is equal to theta. And this represents the value of our second approximation to theta. So I'm going to call that theta 2. So theta 2 is equal to 2.5655 and so on. And I've already stated that's the second approximation to theta. So therefore, theta 2 is equal to 2.57, correct to 2 decimal places.